In this example, we're going to see how to find the slope of the tangent line to the curve f at a specific point xy equals a for the x partner, f of a for the y partner. Solution. What are we looking for? We see the slope m of a tangent line to the function f at the ordered pair xy equals a f of a. Let's draw a sketch of some function f of x. Here's our y-axis, our x-axis, and here's our curve f, and here's the point a on the x-axis and its y partner f of a on the y-axis. We can see that there's a point at a f of a, and there's a line that's tangent to the curve through that point, a f of a. Okay, step one, consider the slope of a neighbor line, specifically the secant line that passes through the ordered pair xy equals a f of a and xy equals something just a little bigger than a plus h, and its y partner, f of a plus h. Okay, here's our y-axis, our x-axis. Here's our curve f. Here's a on the x-axis. Here's its y partner, f of a, on the y-axis. Now here's a value just a little bigger than a. It's x equals a plus h, and its y partner is f of a plus h. So those 2 points that we just mentioned have a line that passed through them. That's the secant line. We want to get this thing to look like the tangent that we have in the picture above. This is our secant. Now, slope in general is equal to the change in the y values over the change in the x values. For this picture, we call y as f. So the slope is f of a plus h minus f of a over the difference in the x values, a plus h minus a. That gives us f of a plus h minus f of a over h, where h, if you look at the sketch, it's just the distance between our two x values, x equals a and x equals a plus h. Okay, step 2, we are going to approximate the tangent line, the line that's tangent to the function f at the ordered pair xy equals a f of a. And we're going to do that by nailing down the secant line. We're going to nail it down at the point, that single point we want the line to pass through. That is the ordered pair xy equals a f of a. And we're going to twist that secant line so that is the only point that it passes through. How do we do that? Well, here's the y-axis, here's the x-axis. Let's see, here's our curve f. Here's the point x equals a. Here's its y partner, f of a. Here's our second point, a plus h, and its y partner, f of a plus h. And then here's that secant line that connects those 2 points together. Okay, we're going to nail this graph down at the ordered pair a f of a, and then we're going to twist. As you see, what happens is we twist this secant line nailed down at that ordered pair a f of a. It's getting closer and closer to becoming the tangent line that touches the graph f only at that single point, a f of a. So we're approximating the tangent line by twisting this secant line. What does it mean to twist the secant line? Well, mathematically, we do this twisting thing by taking the limit as the distance between a and a plus h on the x-axis goes to 0. So as h goes to 0, we take that limit of f of a plus h minus f of a over h. And you can see as that value h goes to 0, there's no distance between a and a plus h, and we've got our tangent line. Conclusion. We've developed this result. The slope of the tangent to the function f, or the curve f, at the point xy equals a comma f of a is this limit that we just found. M equals a limit as h goes to 0 of f of a plus h minus this f of a over h. So there it is. There's a formula, the slope of the tangent of the curve to the curve f at the point a f of a.